11.8, which is about power series. So I want to start by defining what a power series is. A power series is a series of the form C sub n x to the n, where x is a variable and CNs are constants called coefficients. Of the series. So I think we saw some, probably in our homework on web assign, there were some series that had a variable x in it. So that was a preemptive example of a power series. Okay. So let's write out what this series looks like. Cn x to the n, C0, C1x plus C2x squared, C3x cubed. And these C0, C1, C2, C3, they're all just coefficients. They're constants. So anytime I come across something new, we want to see an example of that. So the example we're going to consider, let's say all these coefficients are 1. So Cn is going to be 1 for all n. So now the series I'm looking at is really just x to the n, which is 1 plus x squared plus x cubed, and so forth. And x is just a variable. So let's plug in some numbers for x and see what happens. Let's start by letting x equal 1/2. So what terms do I have in my series? So here we're going to have 1/2 to the n. So 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16. It's a geometric series, right? So this is familiar to us. This is a geometric series. I need to know what my value of r is. 1/2. Can someone tell me if does that mean that the series converges or diverges? The absolute value of r needs to be less than 1 to converge. This is less than 1, so it converges. So I plugged in one value, I plugged in 1/2, and I got that it converged. Let's try plugging in a different number. Let's plug in 2. So the series I'm looking at is 2 to the n. So that's going to be 1 plus 2 plus 4 plus 8 plus 16 plus 1 over 16 plus 2 plus 4 plus 8 plus 16 plus 1 over 16 plus 2 plus 4 plus 8 plus 16 plus 1 over 16 plus 2 plus 4 plus 8 plus 16 plus 1 over 16 plus 2 plus 4 plus 8 plus 16 plus 1 over 16 plus 2 plus 4 plus 8 plus 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 What about this series?
It diverges.
It diverges. What kind of series is it?
Geometric.
It's still geometric, right? If I take and divide any two consecutive numbers together, I get 2. So this is a geometric series. My R is 2, which is bigger than 1. So it diverges. Okay, so when we let x equal 2, it diverged. But these they share a commonality, right? In both cases, what types of series did I have? They were both geometric. So in general, if you look back at your series that we had at the beginning, which was x to the n, so this was 1 plus x squared plus x cubed. This is actually going to be a geometric series. What's my ratio for this series? X. Okay. Take x and divide by 1, I get x. Take x squared, divide by x, I get x. So I know exactly, though, when a geometric series converges. This series converges if the absolute value of r, which is now the absolute value of x, is less than 1. So it converges if x is between -1 and 1. And it's going to diverge. Don't do that. It's going to diverge if the absolute value of x is greater than or equal to 1. So what we just found out is that when I plug in some values of x, sometimes it converges and sometimes it diverges, okay? So a power series may converge for some values of x and diverge for other values of x. So sometimes it converges, sometimes it diverges. And so what we're really interested in is when does the series converge? What values of x is the power series going to converge? So I need to give you the general form first of a power series. So the one I gave you at the beginning is not the most general formula for a power series. This is the general formula, Cn x minus a to the n. So if you let a be 0, you get what I wrote at the beginning, x to the n. So this is the more generalized format for a power series. And what we say is that this is the power series centered at A, or you might also see it phrased as the power series about A. That's the two most common ways that we describe that power series, centered at A or about A. And I really want to know, when does this series, when does it converge? So I want to plug in values of x. Well, let's start by plugging in A. and seeing what we get in our series. Cn a minus a to the n so a minus a, that's just 0. What's 0 to a power? It's just 0, right? There is one caveat. I'm saying 0 to the 0 is also 0, which is not necessarily true, but that's the convention that we're going to take here. So it looks like I'm summing up 0. And I want to know, does this series converge or diverge? It converges. Why do you say converges?
Because r is less than 1, but like they all go to 0. So.
Yeah, so you could think of this as a geometric series where your r is 0.
It's also just a constant.
It's also, well, yeah, it's also just a constant. But more importantly, it's not any old constant. It's 0. So when you look at the partial sums here, Sn, I'm adding up 0 n times, which is just 0. And then you take the limit of these partial sums and you're going to get 0. So the partial sums converge, which tells me series converges. So no matter what power series you start with, you automatically know it converges for the value A. Okay? So what we just learned is that the power series always converges. Always converges for x equals to a. So I know one value where my power series converges. But again, our overall question, our motivating question here is going to be for what values of x does a particular power series converge. We found one value, but I want to find all of the values for which it converged. So like the example we did, x to the n, I gave all values where it converged. Any number between -1 and 1, the series converges. Every other value, it diverges. So I want to know all possible values where it converges.